Awesome. Well, thank you. Good morning, Houston. I can't see you with these blinding lights. I'm Don Zoldi, CEO of P3 Tech Consulting. So great to have you here. We're going to be talking about complex and advanced operations in the context of the energy sector and some of the challenges that remain, but also some of the promises going forward. So without further ado, I'm going to go ahead and let my panelists, I guess, here introduce themselves. Let's go first with you, Ade. This is Ade Famadi from Microsoft.
Hi, everyone. I'm Ade Famoti. I'm a senior director for AI and robotics at Microsoft. I lead strategic partnerships, business and go-to-markets for Product AirSim, robotics and AI simulator.
All right, next up, Don Berchoff.
Hi, I'm Don Berchoff, CEO of TruWeather Solutions. We're focusing on the micro-weather problem that is causing, unfortunately, unnecessary groundings because of a lack of certainty in the weather, and we're working on closing those data gaps and building analytic tools to help in decision-making.
All right, before we get into the meat of this, let me ask you all a question. How many of you are using air assets right now in your operations in the energy sector? Okay. I see a handful, literally. Okay, let's go ahead and ask a little slightly differently. How many of you desire to use air assets in your energy operations? One additional. Okay, two additional. Okay. All right. So maybe what we should do first is talk a little bit about the benefits of using air assets, whether it's smaller drones, larger cargo drones, and advanced air mobility in support of the energy sector. Who wants to take that first?
I can start with that. So, I know I've been down here 2 years now, and I understand that most of the focus on using drones is for inspection, looking for methane gas leaks, or inspecting electrical lines and things of that nature. So I think, most folks understand the cost of having a human do that and the cost to their safety even sometimes of doing that. And I think it's pretty clear that the drone with the right tools and the right techniques and the right design can really reduce the cost of those operations while also even increasing them potentially. Because right now, you may go out and have to inspect for methane, and we're doing it by hand, having somebody walk along the line. How often could you do that? It's very costly, right? Yeah. So I think that's, from what I've heard here, the second area that I'm interested in hearing is, why aren't we using drones more frequently for moving stuff offshore, right, to different platforms and things of that nature? I think part of that is, it's a little more challenging environment, and, weather, I'm going to talk a lot about weather. Weather's a big issue over the Gulf. Right, so I think that's a hurdle that people are trying to work through. But yeah, I think that's my perspective. I mean, it just saves money, saves lives, protects people, and get more accomplished, right? Cheaper.
Did you want to add anything to this one?
No, just siding with Don on those points. What we're seeing also is a more relaxed regulatory posture around drones for inspection, eyes in the sky. For inspection grids, wind turbines, where we could have hazards to humans. So just that more relaxed regulatory posture has absolutely just made just the entry bar a lot lower, and we're going to see a lot more proliferation of that in the industry. So yeah.
Yeah, I'm going to jump in here, and let's just get real, right? So what I'm hearing, and by the way, I ran the Law Tech Connect Energy Edition on Monday, and we had some amazing speakers. Don was one of them. And just having conversations with folks, walking the floor, it's clear that the energy sector is leaning more heavily towards robotics and ground and maritime robotics because, frankly, the regulatory structure, while being a little bit more relaxed than it was, say, 3 years ago, is still not where it needs to be, right? Beyond visual line of sight still remains the holy grail. I know I'm preaching to the choir here. And that's not the only challenge. Some of this is technological, some of it is weather related. So I want to go to you, Ade, and talk a little bit about what you're doing vis-a-vis simulations to help kind of build that safety case, that comfort in the regulators and in industry to show that these operations are possible and they are safe.
Thanks, Don. So at Microsoft, we have a platform called Project AirSim. It's a robotics simulator, and it supports a spectrum of drones, inspection drones, eyes in the sky, drones that could do infrastructure-grade inspections, power lines, wind turbines, et cetera. Drones that could support delivery. So think about the last mile scenario or the mid-mile scenario between cities or perhaps towns. And think about the extreme far spectrum of that, the urban air mobility. So think about air taxis, more evolving and novel airframes around urban air mobility. So Product AirSim is a platform to help the robot simulate in the wild before it goes in the wild. So think about the physics, just simulating the physics, the sensors, LiDAR, radar, the RGB cameras, depth, the range of sensors on drones. And think about just the kinematics of the vehicle. So think about the robot, how it, if it's an aircraft, how it yaws, pitches and rolls in sim before it flies. The other dimension to Product AirSim and the dimension we're coming at this is the simulation provides a virtual hyper-realistic 3D world where you could mirror in sim exactly how the drone flies in the real world, either using geosynthetic data, geotypical data, or geospecific data. And what that allows the drone to do is collect data at scale to go train AI models to fine-tune perception sensors, perception-based sensors, like RGB cameras, LiDAR, thermal, and a range of sensors like that. So that's the unique dimension we're coming at this. We're not doing this alone. We're working with partners like NASA. Some of the folks are Ames. We're working with regulators also, those in the US like the FAA and in the European domain as well. And that's the dimension we're coming at this. So it's a unique perspective across in supporting what I call 3 tiers. One of those tiers is really simulating robots and flying robots is really expensive. So we provide that platform to support perception action loops in the wild. That is expensive, so the robots don't have to have unplanned landings when they go out in the real world.
Unplanned landing is a nice way to say crash, so if you've never heard that term.
Yeah, thanks, Don.
Okay, you're welcome, you know.
So the second tier is really around certification, just the sheer number of hours you have to fly. So for folks who are familiar with the FAA DNR durability and reliability pathway, you have to fly almost an inordinate amount of hours. So simulation allows you as almost like a pathway to almost navigate or circumnavigate some of those hours. I'm not speaking for the FAA, but those are options that, or dimensions we're looking at. And the third tier is really around safety. The myriad of options, of approaches, of corner cases that you cannot run in real life, you get to run that in sim. So think about how you could inject faults, introduce errors into the drone, but not in real life, but in sim. So those are the kind of top 3 tiers that we're looking at using Product AirSim.
Awesome, and I imagine at some point you could work with Don and inject weather. And that's a good way to pitch it over to you and talk a little bit about the weather challenges in particular. Okay, so not just in urban environments and some of the, with the buildings and the wind, but also, out above water. Mm-hmm. Because, with the offshore energy, what are we seeing in terms of, let's just call it specialized weather needs?
Well, we have the aviation weather system today that was really built in the 1940s. And, TAFs and METARs, which some of you are familiar with, there's really no reason to have those coded the way they are. The reason they're coded that way is because in the 1940s, you had to keep it to a limited number of characters to get over the teletype. And in a lot of ways, the weather systems we're using today are still 1980s, 1990s. Even though you get this pretty app and it looks really good, it doesn't mean it's accurate. Everything that you're using today is model-based, and that model is not accurate all the time. I think you've found that out. The only way we're gonna fix this problem of uncertainty that you're dealing with is by getting better data. You can't model something and improve it if you don't have better inputs. And right now, we have no data below 5,000 feet hardly in the atmosphere. We measure 2 balloon launches a day at 88 sites. We have some aircraft that land at airports. Everywhere else, it's just a model that's taking that data and the satellite data, which is good down to about 5,000 feet, and just trying to estimate what those winds are doing. It cannot pick up the local effects of the water, cannot pick up the local terrain effects. It can't pick up the afternoon heating. So when you see winds that are 2 times stronger at 400 feet or 300 feet than what we're forecasted, that's just a limitation in the science. So what TruWeather's working on is saying, look, we need to get better data. There's no free lunch here. Everyone says, I need free data, I want to use free data, I don't want to pay for weather data, but it's costing you. 30% of manned aviation today that's canceled or delayed due to weather could have flown. The reason it doesn't fly is because of the lack of certainty in the data. This is going to be the same thing. It's translating right now. I talk to drone delivery companies all the time. They're getting a 30%, 40% attrit rate, and that's not a sustainable business model. So what we've got to do is get better data to feed those systems so we can anticipate. Probably 30% of the time when they attrit today, they could fly. That's the goal. We have to get you flying in as close to 100% weather tolerant conditions as possible. And we could do that. There's a lot of low-hanging fruit. But we've got to get our mind away from this free concept, because free's costing you a lot of money. And we believe there's a 3 to 5 to 1 return on investment that we can get back in saving money, in generating more revenue, and making yourself more responsive if we have better data. So that's what we're focusing on. When you go on a place, if you go over like the Gulf of Mexico, and you're trying to fly at 400 or lower feet, you don't know the microclimate you're going through. Just the water temperature changes over hundreds of feet. It causes these microclimates that can increase winds. You can have a low-level wind jet that will not get measured, will not be picked up. So the advantage we have today, and the reason why helicopters could fly and general aviation can fly, is because there's a pilot on board. Most of the time, that pilot is the last line of defense, and they're the best weather sensor we've ever had. You could talk to helicopter pilots about some of the really hairy situations they get into and they get out of. We don't have the pilot anymore on board the aircraft. All the heuristics are gone. They're trying to fly an aircraft 10, 15 kilometers from 200 miles away. They don't even wake up in the same environment they're operating in. There is no way they can know what they don't know. And we have to close that gap. And so those are the issues that we've got to work through in order to make this, really scale this industry to be very, very systematic, reliable, and predictable, and to increase the revenue and the profit.
Yeah, absolutely. By the way, if you go on TruWeather's website, or even mine, P3 Tech, there's a white paper talking about the National Weather Sensor Network that Don has been putting together for a while. So I'm going to ask you, Ade, is it possible to inject weather into your simulations to help kind of validate what Don is saying?
Yeah, absolutely. So weather is a critical part of drone operations and flying. And I think Don alluded to this. The old airspace rules in regulated and unregulated space is largely rules-based. With simulation, we take a data-driven approach. So basically, you could now introduce real-life data, air traffic data, UTM data, real weather, real time of day into simulation. So you can get almost a precision output of what the drone operations will look like in real life. So we take that approach. You can introduce real-time weather. We're working with partners today who offer those capabilities. And of course, I would say, Don, TruWeather, and Product Airsym do have a mutual customer that we may be exploring in the future as well.
So knowing what the weather, by the way, I took the Part 107 test, that's why I went like this on METARs. I was like, ooh, that was fun to study. But
totally unnecessary, too.
I told him, by the way, I still don't understand dew points, but, look, I'm a drone pilot, I'm looking at this thing, what I want to know, I don't want to know just the weather, right? I don't want to have to interpret this. I want to know go, no go. And not only do I want to know go, no go, I want to go understand the probability of danger or risk in that operation. In other words, you're saying, like, let's pick up this 30% of lost flights off the floor and get you flying. Well, what's my risk? What's my probability of risk when I'm doing that? So how are you tackling that, Don?
Well, so my background, I was 24 years Air Force. I built big regional weather centers, but I also ran a logistics base in Central Asia. So I ran Manas Air Base for a year, which was the main staging base in Afghanistan. I had all the tankers, we had all the cargo going through, and that was kind of my weather lab. I was in charge, so I could tell people how to operate. And so when we did that, we got back that 30% because I was on both sides. I was the decision maker and I was the forecaster. So
I'm going to digress. I want you to tell them the story about, it's not a story, it's true. In Afghanistan, I think it was, when you got Kyrgyzstan, when you got 12 inches of snow in one day, and you kept the planes flying somehow.
Yeah, so if anyone has ever been involved in aviation, you know that if you get 12 inches of snow in 5 hours, even an all-weather aircraft that are not really all-weather can't deal with that, right? So think about any airport, 12 inches of snow in 5 hours. That's a lot of snow. I saw her coming 2 days in advance, and I told my civil engineers, we are going to keep these tankers flying over Afghanistan, because our tankers were refueling A-10s, which were protecting the troops on the ground. And if we didn't get those tankers up, they would be susceptible. So we set it up, and I'm very proud to say that we kept them flying in 12 inches of snow in 5 hours. I got some amazing pictures. So it's all about preparation, but it's also about certainty, right? So weather's uncertain. There's nothing we can do about that, right? But what we can do is we can try to really understand that uncertainty, quantify it better by collecting better data. If you're using other weather apps, they're not doing that. They're just taking a model and throwing it out there, and there's uncertainty there. What we want to do is we want to get better data to train these models to understand what the uncertainty is with real data, validate it, and then once we validate that, we could tell you with general certainty, hey, 40% chance of rain that is going to increase beyond an intensity that's impactful to your operation, right? So, some drones can fly in rain, some can't, whatever. Some of them can fly in rain, but they can't fly in heavy rain. A lot of it has to do with battery power, right? Just knowing how much force is up against the drone. This is a science problem that we have to start getting our head around. And if we get better weather data, and I can tell you 40% of the time when this happens, you could go back and look and say, okay, what's my risk of going when it rains? And if we say that it's going to be exceeding a threshold, what's my risk of going if it's a 40% chance? So let's assume that you have one incident whenever you fly in rain that exceeds your threshold, you have one incident out of 20. That means you have a 5% risk of crashing in that event when the threshold is exceeded.
Wait, what's it called?
Unplanned landing.
Unplanned landing.
Yeah,
Okay.
Sorry, you have an unplanned landing. Well, if we know that when you exceed that number, your risk is 5% of an unplanned landing, we can then take our 40% probability and we can run actuary on that and tell you what is the probability number you care about. Is it 20% chance is when you start crossing a line that you don't want to deal with the consequence? And we can put that machine to machine into your analytics, and you can have automated decision making that's taking into account weather uncertainty and what the risk tolerance you're willing to take, and that will help you get back to 30%. And you'll have a systematic approach to it, not somebody that thinks they're a weather person, because a lot of people think they're weather people, because they look at their app. No, that's not the way you want to do this, because we're doing everything with precision in this industry: comms, detect and avoid, engineering. And now we're depending on somebody who thinks they're a weather person to look at an app that may not be accurate to make your decision. That's where your long pole is in your tent. It's costing you money by doing that. And that has to change. We've got to get this, looking at this systematically. And that's what I'm hoping CFOs and CEOs will understand in this process.
I like to pitch it back to you and then over to Ade. So part of that change is also changing the minds of the regulators. We talked a little bit about regulation, but not deeply here. Standards bodies as well. And Don, you've been very active in ASTM's 38. Tell us just very briefly about the work there and what you believe in the future that weather standard will be.
So right now we're operating under standards that were made in the 1940s, which say you have to have certified instrument in order to make a flight control decision. That's why you're all forced to use those METARs you don't understand how to read, right? Because you have to use the nearest certified instrument, which is at an airport. Well, we know how relevant that is to most of you where you're flying. You're being grounded because of a METAR that's not even relevant to where you are. So what I started about 4 years ago is I went to the FAA and said, look, we need to close these gaps. We need to close these weather gaps. That's a safety issue. And we have technology today that the sensor technology has advanced so greatly that there's ways that we can do data performance standard here rather than a certification standard. And it took me 2 years, but they bought into it. And now we're developing that standard, which will allow you to use other weather data sources as long as they've been quantified and validated with some kind of a certainty in the era. And that will be metadata that's attached to that observation. And once that's approved by some third party, which could be a reference network it uses to determine the goodness of that data, it will then be allowed to be put into the system for UTM. And we will then have people that will want to get sensors out that are lower cost that could feed the system, which will then be like a crowdsourcing. So we're working right now with Crown Castle Tower, TruWeather is, to get these new sensors on top of towers that will see the winds up to 6,000 feet using LiDAR technology. Those types of technologies will be allowed then under this standard. And so we're going to ballot next month. The FAA's plan is to take about a 2-year period to do the risk assessment on this new standard. We're going to collect data. We're looking at working with companies that we think we can get waivers to use our techniques in their operations to collect that data and give it back to the FAA. And then in hopefully 18 to 24 months, we'll have an advisory circular. And this will change the whole way weather is used in aviation.
It is a game changer. And speaking of game changers, so tell us a little bit about then how you all are working with the regulators. You mentioned, now NASA, to be clear, is not a regulator, everybody. You probably know that, but I think some people get confused by that because they're very active in this UTM or UAS traffic management, research and development and whatnot. But what have you seen from a regulatory side, working with the regulators and your simulator? Like what vibe are you getting from them?
Thanks, Don. So like Don, we're staying close to the standards, the SDOs, the standards development orgs, ASTM, SAE, EUROCAI, super closely. But the regulators also, so not just working with the likes of NASA, who's not a regulator, but influences ultimately what passes into regulation in some way. We're working with the folks at the FAA Next Gen, for example, thinking about what the future looks like for autonomy, for urban air mobility, for advanced air mobility, and just getting some signals, some regulatory signals for what that could look like. So for example, what's the role of simulation in UAV operations, in type certification, in type certifying aircraft, and evolving perhaps the role of AI and this new arc of AI in autonomy in the aerospace. So those sort of signals, those conversations are happening on an ongoing basis with the folks at NextGen. Also, our regulatory stakeholders in Europe, like EASA, who are supporting evolving standards like the SORA-based methodology, supporting UAV operations in Europe for low-risk operations. We're also having those discussions also. Getting the regulatory signals for what prevails in Europe, which ultimately will affect even places like the UK. They're not part of EASA anymore, but the CAA. What sort of posture are they taking? So that's the approach we're taking. Simulation has an integral role, we believe, in the future of autonomy, UAV operations, type certifications. If you look at the FAA DNR pathway, the durability and reliability pathway, it stipulates based on the population density. If you're going to fly over a large population density, there's certain numbers of hours you have to fly, number of tick boxes you have to tick off. And for a small drone startup, either an OEM or an operator, you can imagine what sort of task, how arduous this task could be. So simulation plays a role there. And think about autonomy in the airspace from Class A to Class George airspace. Once you introduce autonomy UAV operations, the rules-based systems start to become a lot more legacy. So you now need more data-driven methods, which simulation could play a good role. So that's the sort of approach and lens we're looking at this.
Well, it makes sense. I don't think it's a tough sell today because the military's been using simulations for a long time. And in fact, I think is even more so going to that, especially for the remotely piloted aircraft pilots. For those who don't know, I was almost 25 years in the United States Air Force, retired colonel. So I've been and retired out of the United States Air Force Academy. So I know they're training cadets using sims, and there's even been physiological research, right, to show that seeing something in front of a screen, even though you're not physically there, has that same impact on the human body physiologically. So great work you're doing, and I don't think it's a huge logical leap to understand that this can play a role and can actually be safer as well.
Absolutely.
And when you think about manned, of course, crewed aviation, you know, the fuel and all the savings that go along with that, in addition to safety, I think is really critical. Well, we're down to 5 minutes, and I want to make sure both of you have a chance to finish out strong and talk about, make sure this audience understands, you know, the message you're trying to have them receive. So, Don, I'll go with you first, and then we'll end with a day. So, over to you.
So, you know, what's next in UAV operations? It's BVLOS. BVLOS is the silver bullet. I mean, that's where people are going to make money.
And we assume everybody knows this, but beyond visual line of sight.
I'm sorry.
I mean, we're hearing a lot of acronyms, and not everybody is familiar with drones.
Yeah, that's true.
So beyond visual line of sight.
Yeah, by the way, we are focusing on autonomous ground weather also, just to mention that. You know, and so everything is combined here. It's ground and air, intermodal, setting up a system that weather data is much more resolute, a little more certainty, that you can make better decisions to manage your assets, right? So in the end, it really comes down to cost, revenue, and responsiveness. And so, you know, if you're sending people out to fly and they can't fly because of the weather, and you could have avoided that, that's money, right? They could be doing something else. If you're not flying because you think the weather is going to be bad, you're not generating revenue on that aircraft. And if you want to be responsive, like in a public safety perspective, you know, you want to make sure that if you can get somewhere, you can get there to save lives, right? And weather is the longest pole in the tent. You know, there is something we could do about it. You know, I talked to somebody yesterday, well, that's God's will. I said, well, maybe God's will, but God also gave us the tools to mitigate that problem. So you know, that's the way I look at it, right? And there are tools. I think that, keep in mind, when you're talking about drone operations or eVTOL operations or air taxi operations, wind is going to be the biggest factor, and we don't have very good wind measurements. So it's all about weight, how much payload you can carry, which is money, right? If you can't carry as much, you're not making as much. It's about distance traveled. It's about recharge time. If you're trying to, you know, do a logistics chain, and you're like a drone delivery company that wants to turn 60 aircraft an hour, if you have a headwind that day that you don't know about, and it's more significant than you expect, your recharge times are going to be longer. What's that going to do to your flow? Logistics turns into a mess with weather. And I've been there and I've done it because I was at the Tanker Airlift Control Center at Scott Air Force Base, which is the biggest airline, you know, airlift and tanker operation in the world. We flew 100,000 missions a year. We had 5,000 delays when I showed up due to weather. When I left, they were only having 1,800 a year. And we didn't even improve the data. It was just all around the risk management and the way you use the data. And that's what we're trying to accomplish. And we're very confident that if somebody takes this seriously and has a weather strategy and just doesn't think it's just the same old, we can get those same kind of results.
Awesome. Over to you, Uday.
Great comments, Don. So I just want 2 comments real quick. First is I want to piggyback off the comment Don made about the military. The military, and in the case of the U.S., the Department of Defense is the largest customer of autonomy in UAVs in the U.S., perhaps presumably in the world. So the way we're going to evolve UAV operations, this whole industry, is through ecosystem partnerships with the Department of Defense and the military. So at Microsoft, with Project AirSim, we have partnership with the likes of Doppler, AFWorks, AFRO Research Lab, the Army Research Lab, Doppler, some of those research players in the Department of Defense, just to evolve this market space, just to ensure that we're taking learnings from the military and we're cross-pollinated into commercial segments. So that's a critical part of how we advance this whole ecosystem. The second is we're in an arc of AI. And that has a broad role to play in next generation UAV operations as well. If you think about business and technical challenges we're trying to solve. So think about drones in the sky and GPS denied environments and C2 denied environments. You could train those sort of scenarios in simulation. Using visual SLAM, visual odometry for some of the roboticists in the room. So your drones know how to fly in sim when they get denied in real life. If you think about strategic deconfliction, tactical deconfliction in airspace, you're not going to go test that out in the real airspace. Simulation provides a testing ground to test out, deconfliction techniques and collision avoidance in sim as well. So this growing arc of AI has a big role to play as well as we think about next-gen UAV operations.
All right. Well, 23 seconds left. That's all she wrote. We are going to end on time and respect your time. So thank you both so much.
Thank
That
you.
was awesome.
Thank you.
Dawn.
Thank you very much to our
As
panel.
always.